Welcome to Study Guide Forum. Today we are going to be looking at a question that has to do with bearing and distance. Here the question says that the points x, y, and z are located such that y is 15 kilometers south of x, z is 20 kilometers from x on a bearing of 270 degrees Celsius. Calculate correctly to two significant figures y and z, talking about the distance here. And again we have the nearest degree, the bearing of y from z, the bearing of y from z. So before we continue, if you are joining us for the first time, we encourage you to subscribe to our channel, and then so that you get more of our videos and enjoy the fun of staying with us. And we also encourage you to like the video, and then leave your comment. If you have any question, you can leave it as a comment, and I will also encourage you to watch to the end so that you will also understand the basic ways of really tackling questions that has to do with bearing and distance. This used to be a problem to some students, so that at the end of this video it will never be a problem to you anymore. So here, let's go back to the board. Here we have question that we're supposed to be answering here. This is number one and number two. So before we do that, we need to make a sketch of it, make make a diagram of what we are expected to do. You say that we have points x, y, z, x, y, z, and then from the information given to us, say that y is 15 kilometers south of x. That means if we have this is our x, this is our s. If this thing is our s, we know that east is here, west is here, north is here, and south is here. Then if it says that it's south, 15 kilometers south of where, that means this is the south of the x. This is the x. The south of this x, we have 15 kilometers from the south of the s is where we get what? We get the y. We put our y here. That is what it means. South of what? X. That is what it means. What it means there. Then the next one is said that z is 20 kilometers from x on a bearing of 270 degrees Celsius. So now it means that wherever z is, it's on the bearing of 270 degrees Celsius from what? X. That means you know that from this point to here we have 90, another 90, then the next 90 here will give us 270, meaning that at this point where we have the 270, all along here, once we were able to get 20 kilometer, we have our y. We have our, okay, sorry, now this is z. We have our z. That means the point we move along this bearing and get 20 kilometer, that is where we have our what? Z. Now the next thing we are doing here is say that the question, now we come to the question, we say that calculate the distance. That is the distance between here, z, and what? Y and z. This is the distance we are looking for. So if that is what we are looking for this place. This is our y and what? Z, where we're looking for. And in this case, now we have the diagram of what we're looking for. So the next we are going to do here, we are going to solve the problem. Now we know that based on what we have here, this is 90, here is 90, here is 90. Now we can also go with Pythagorean's principle, where we square this, square that to get the hypotenuse, or we can also use the cosine rule in getting it done. But the fastest method of doing this is just to go by Pythagorean's principle, where we have y z squared is equal to 20 squared plus 15 squared. 20 squared will give us 400 plus 15 squared, that will give us 225. And that will give us 225. Let me just confirm. Okay, 225, yes. Now the next thing we do, we add it up. 225 plus 400. 225 plus 400, we have that will give us 625 y z squared. That means y z will then be square root of what? 625. Square root of 625 will then be, we have, is equal to 25 kilometer. 25 kilometer, that is what we have. This is done. That means we have the first question we are asked to find. The next one we're doing here is say that calculate the, that is the bearing, calculate the bearing, calculate correctly to the nearest degree the bearing of y from z. That means bearing of y from z. When we are calculating this bearing, note the bearing moves like this. This is this our bearing is a 3-digit bearing. In 3-digit bearing, it normally move from z, from north down. So which means the bearing of z, y from z will be this. But we don't know this one. We can call it what? Theta. So but we know that from what we have here, this is 90. That means here also 90. So we need this angle to add up to what we have here. The alternate angle, note this is 90 here. Alternate angle to this one is also 90. This is 90, 90. Then we don't know what we have here. So by getting whatever we have here, then adding it to 90, we will then have our bearing of what? Bearing of y from what? Z. So let's quickly do that. So to do that, we know that since, because it's still a right angle triangle, we can say, remember we have our SOHCAHTOA, and in this sine opposite hypotenuse cos adjacent hypotenuse. Here we have tan opposite adjacent. Now we have our, this is opposite to this angle, this is adjacent to the angle, so we can go with opposite, we can go with TOA, that is tangent. Theta is equal to opposite. This is our opposite to the angle, 15 over what? 20, which is the adjacent to the angle. Now when we find, that is 15 divided by 20, we have to give us our theta is 0.75. Now to get the actual value of this theta in angles, then what we do here is, it means that our angle here will then be, our theta is equal to 36.9. Now say to the nearest degree. Since we're talking about the nearest degree, we can say is what? 37 degree. That is, now this is what we have. The theta is 37 degree. Now the bearing itself, what we do about the bearing is that 90, bearing of what? Y from Z will then be equal to 90 plus 37. That will give us, this will give us 7 here, 9, 10, 11, 12. That means 127 degree. Thank you so much for being part of the class. We encourage you to like, share, and subscribe if you have not. Thank you for getting this far. And then if you have any question, never hesitate to leave it at the comment section. And meanwhile, what we have here will also appear in the description of this video. Thank you so much.